But the bottom line is you're kind of describing diabetes of the brain is what it sounds like.
Yes. In fact, it's sometimes called diabetes of the brain. So this is how we kind of came upon this. So we were studying this pathway where animals use fructose to become obese, and they become insulin resistant. When you eat fructose, you can induce insulin resistance and you can induce obesity, not only in animals, but in people. And another big finding was that we discovered that the body can make fructose. So it isn't just the sugar you're eating, but things like high glycemic carbs, like rice, potatoes, and salty foods can all act to increase fructose production. So now we found that when animals were eating a lot of glycemic carbs, they were making fructose, and this was driving a drop in ATP, insulin resistance, and actually low-grade inflammation. So here I am, I'm not a neurologist, and I go, wait, fructose causes low ATP. It's the only nutrient that does. It causes it causes inflammation, and it causes insulin resistance. This is what we see in the brain of patients with Alzheimer's. So we started looking, and we go, you know what? Actually, eating sugar is associated with increased risk for Alzheimer's. Eating high fructose corn syrup is associated with an increased risk for Alzheimer's. And also these foods that make fructose, like high glycemic carbs and salty food, by gosh, they can increase the risk for Alzheimer's. And obesity, which is driven by fructose, and diabetes, they increase the risk. So we have an epidemiologic link, right? Yeah. So then we gave fructose to animals, and actually a lot of these were done by other groups. But if you give fructose to animals, guess what happens? After about 6 weeks, the animals start having trouble remembering things. Like you can put the laboratory rat into a maze, and it will find its way through the maze, and you can time how long it gets through there. And a normal rat, each time it goes through it, does it a little bit faster. They learn. But if you give them sugar or high fructose corn syrup, they don't learn. They continue to take a long time to get through the maze. So we know that they're having some what we call cognitive dysfunction, some problems with thinking. And then when you look in their brain, you find a drop in ATP in the cells. You find low suppression of these energy factors. We find insulin resistance, and we find neuroinflammation. And if you keep giving sugar, over time they start getting amyloid plaques and tau protein. So it seems like it's very likely the mechanism, right? It's showing the whole pathway. Then if you look at patients with Alzheimer's and you measure fructose levels in their brain, they're high. They're high. So all these things sort of fit. So we go, oh my gosh, could it be diet? It probably is diet. And so, but I'll tell you the coolest evidence. I think this is the coolest evidence. So I told you that this switch, drops ATP in cells, right? And that characterizes Alzheimer's. But what's really interesting is Alzheimer's tends to affect certain regions of the brain more than others. And no one's really ever been able to understand that. Why would it affect, the cerebral temporal cortex, but not so much the occipital cortex? And why does it affect the posterior cingulate cortex and not the anterior cingulate cortex? And so it's sort of been a mystery, right? So it turns out that when that this foraging response that's driven by fructose. So when you give fructose to an animal, they start foraging for food. Okay, now foraging, and if you give sugar to your kid, you'll see that they get hyperactive and they're running around and they're often hungry.
Are you leading me to the wandering behavior in Alzheimer's?
Yeah, well, we'll get there. Actually, I am taking you there, but this is actually sort of more dramatic. What I'm going to tell you. So what happens is. So there's certain regions of the brain that tend to be affected by Alzheimer's and others that are not. And fructose also tends to affect certain regions of the brains and others not so much. So it turns out that foraging is where it's at. So the foraging behavior initiated by fructose requires certain behaviors. You have to be able to wander into areas and look around. You have to keep moving. You can't deliberate. You have to look and make quick decisions. You can't have a lot of self-control because you've got to go into areas that are dangerous. And if you have too much self-control, you don't want to go into the lion's den because you know you might get hurt. But here you have to have kind of that impulsivity, that bravery to go and do things sort of dangerous because when you're foraging, you have to find food even in areas where there may be predators. So you have to be strong and brave and impulsive. So it turns out that a lot of our brain is to reason and self-control. And so it turns out that when you drink fructose, if you give fructose to a person, you can show that immediately there's a decrease in blood supply to certain regions of the brain that are involved in self-control. And those are the insulin-sensitive areas like the cortex and like the hippocampus, where it tries to block recent memory. It doesn't want you to remember how dangerous it was last time you were here. So it turns out that things like the hippocampus, which is the recent memory, certain regions of the brain are inhibited by fructose. They become insulin resistant. ATP levels fall. And whereas there are other areas like the occipital cortex, which is really important for like seeing food and identifying visual cues, they call it, where you see a delicious cake, your eyes quickly focus on it. That's the visual cortex. That increases with blood flow when you get fructose. And there's there's a foraging center called the anterior cingulate, and blood flow goes up there, when you eat fructose. And guess what? In Alzheimer's, the disease affects those areas where fructose inhibits that area of the brain. So like the cortex, the hippocampus, it's like a perfect match. And the areas where fructose stimulates blood flow for foraging, like the anterior cingulate, that is preserved in Alzheimer's. It's like one of the last sections ago. So we know that no one's ever been able to map it, but here we got it, and it's a foraging response.
That's
so what we know is that the more sugar you eat, the more fructose you make, the more these areas are going to have their energy go down, become insulin resistant, the less fuel. So it makes sense that those are the areas that start to atrophy, start to have neuronal dropout, and that's where the disease develops.
So that would imply to me that the damage, by the time I'm symptomatic, it's too late, and going to a low sugar, low carb diet is probably not going to make that much difference for me if I'm already symptomatic. Is that correct?
No, you know what? I think that if you start having early memory problems, you're still at a stage where you can really be, helped. And I think that diet is probably the best route to go. And actually probably the very best are like the low carb diets and the keto diets. And there are groups that are looking at this right now. There's been some really surprising and exciting results. And I think that there's a lot of hope. There's also, if you read in my book, Nature Wants Us to Be Fat, I have a copy here. I go through all the foods that actually counter this pathway. There are foods that counter this pathway.